Not sure everyone can hear that on the call, but behind me there are a bunch of church chimes, which means we're pretty much at time. We'll give everyone just another minute or so, 30 seconds to make it into the room, and we'll get started. Look forward to share with everyone today. Real quick, just for some housekeeping. So thank you all for coming today. We have a really great program laid out for you. As our normal webinar series are sort of designed. If you have questions, please post those questions in the chat, and we'll answer them at the end of the session. We've sort of blocked some time to do that. This webinar is being recorded. For those of you who find this later on, we will be mailing out this link to you to share with friends, or you'll find this on our YouTube channel or our website. With that, let's dive right in. So with me today is Dr. Yachi Chen. Dr. Chen is our distinguished data scientist here at Object Computing, and she also leads our data insights team and the consultants that engage in our client projects in data in AI and ML. And additionally with me today is Jimmy Moore. He's a principal data engineer and a senior leader here at Object Computing and our data team. He leads our data engineering group within our data insights team. So welcome, you guys. We have a great program outlined today. So I'll spend a little bit of time just for those of you who are new to our webinar series and to Object Computing. I'll describe a little bit of who we are and what we do here within the technology ecosystem. Then we'll look a little bit about the evolution of how did we get to this topic, because it's really interesting to understand and unpack sort of the journey that we've all been on, both experiencing for those of us who are technologists as proficient, practitioners of our craft, but also as consumers, as people that are experiencing this evolution of technology all around us. And then I'll hand it off to Yachi and Jimmy to walk us through the playbook and a couple examples of some of the work they've been doing and how that playbook has informed and shaped their delivery. And ultimately, we'll wrap up with the Q&A. So if you have questions along the way, please, like I said, post them in the chat, and we'll get to them as promptly as we can. Hold tight. This is going to be a fun ride. So like I said, for those who don't know Object Computing, we're a 30-year-old consultancy here based in St. Louis, Missouri, serving clients for the last 30 years. We focus on a number of technologies, but included in that is AI and ML, and we'll talk a lot about that today as it reflects in our work and efforts in generative AI. But we're also have deep practices in cloud, IoT, application development, security, and blockchain. As a small women-owned business, we've had the pleasure of servicing many industries and many clients over these 30 years, ranging from some early days with folks like Iridium and Express Scripts, through working with clients today associated with Hedera and Tollum Earth, and many companies in between. We're partners with many large technology firms, including our partnerships with AWS, Google Cloud, and Microsoft. What does that all mean? It means if you have a technology need, you're looking at modernizing an application, you're looking at exploring how to bring a new AI model to fruition and deliver successfully, we're happy to help. And we can go very deep in all those areas and everything in between. So with that, let me just introduce a little bit about this timeline, because I think this sets the stage a bit for what we're going to hear about from Yachi and Jimmy regarding the generative AI playbook. As we all have experienced over the last 30 or so years, AI has had an increasing impact in how we think about technology, how we think about solutions, and ultimately how we live our lives, right? Who probably didn't, for those of you not sitting in your basement or in your living room, who hasn't used a navigation system to navigate you from point A to point B? It is in everything we do in a lot of ways, but it just didn't start with navigation didn't just start with generative AI. The kinds of solutions that we're going to talk about today had roots starting as far back as the early 90s around what was going on with the game solutioning around chess and how a computer beat a grandmaster for the first time. We saw the evolution of that when we started seeing these voice devices show up in our kitchens, where we could ask it a question and play a game, or ultimately have it turn on and off our lights. To these larger models that could handle complex games like Go and Google Labs. We have autonomous vehicles, and then we have the invention and launch of OpenAI's ChatGPT, which fundamentally changed how we think about what an AI model is. It didn't just become an object recognition of an image, to now it's not just text, but it's text in context, and text in context and summarization, content generation, and so forth. This explosion here recently is changing the way IT technologists are looking at AI, and ultimately how businesses are thinking about AI. So this is the moment that having the right playbook helps create and propel leaders forward in this new AI-driven ecosystem. And so I'm excited to hand off to Dr. Yachi Chang, who will share with us the OCI playbook on generative AI, and take us through the journey that they've been on these past many months.
Thanks, Andy. There is indeed impressive progress that has happened in the past 20 years, and changes are happening every day. So I often wonder if everyone can be part of the journey, everyone wants to be part of the journey. As an organization, we recognize this can be a confusing and messy space. So we created a playbook to bring you and your AI endeavors to a successful conclusion. So what is a Gen AI playbook? It's a comprehensive guide and recipe that outlines standardized procedures, best practices, methodologies, tools, and frameworks for developing, deploying, and managing Gen AI solutions. There are so many benefits coming from leveraging the playbook, just to name a few. Strategic alignment. A playbook ensures that AI and Gen AI initiatives are aligned with the organization's strategic goals and objectives, maximizing the business impact. Standardization and consistency. A playbook provides a standard approach to implementing AI and Gen AI solutions, ensuring that processes are repeatable and consistent across different projects. Efficiency and speed. By having a predefined set of steps and guidances, teams can avoid the time-consuming task of figuring out each step from scratch, accelerating the development and deployment process. Scalability. A playbook provides a scalable framework that can be adapted to different projects and requirements, making it easier to scale AI initiatives across the organization. Last but not least, the risk mitigation. A playbook often includes common pitfalls and challenges encountered in previous projects, helping teams to anticipate and avoid these issues. In the next 3 slides, I would like to show you the general playbook approach for generative AI engagement. So there are 3 major phases. The most intensive part for phase 1, which you are seeing here, is probably to map the user journey, which maps out the user's experience from their initial interactions with the application to the completion of their objective, highlighting the touch points, the emotions, and potential pain points along the way. The next phase, next slide, please. Thank you. The next phase, 1 needs to evolve your already developed user journey to Gen AI process. For example, you've heard about the conversational AI application like a chatbot as an example. 1 needs to come up with the workflows that map the starting dialogues, routing steps with corresponding flows, as well as ending conversation flows. In the final application phase, you want to start with a POC in order to validate the feasibility and then obtain learnings from those, including gap analysis and the comprehensive testing process. So with that, I want to invite my colleague Jimmy Moore, who has deep real-world expertise in these fields, to walk you through a specific playbook regarding use cases in the manufacturing industry.
Hi there. So how many times have you stood at your equipment wondering, what is going on here? You want to talk and converse with and understand your hardware, but there can be a lot of challenges faced in this space to get down to those root causes. So manufacturers face significant challenges parsing data in varying sizes and structures. There's a large diversity in not just the formats such as CSV, JSON, XML, proprietary formats, and even just plain log data, as well as the structure within those between different pieces of hardware, as well as just different firmware versions. These structures can change. As more and more sensors are made available, we get a higher and higher volume and velocity of streaming data that immediate processing helps it become more useful and valuable, whereas delays can make it challenging to unlock the data within there. Additionally, data quality is huge. Inconsistent or erroneous data needs cleaning and normalization, handling missing data, as well as duplicated data from streaming. Being able to deduplicate is a huge importance, especially when counting and summarizing, developing metrics that you're driving actions on. And lastly, security and compliance. It's really important to have data privacy as we capture more and more data. We need to make sure that we're handling especially sensitive information stored securely, complying not only with industry laws and regulations such as GDPR, CCPA, but also your internal company's sort of higher standards that you hold yourselves to need to be followed. And so robust access control is important, as well as we add on more tools such as LLMs, making sure that we're handling and sharing data that we're allowed to. And so manufacturers really need to navigate these challenges effectively to harness the power of their data. And so we want to walk through sort of what the current solution looks like and see what table stakes are. So for really current solutions that have these diverse data sources and need to develop data lakes, warehouses, middleware and APIs, and master data management. For all of this to work, we need to build bespoke ETL, brittle parsers, and cloud agnostic strategies in order to handle these. And this all becomes very expensive to develop and maintain. So why LLMs? LLMs support lots of different questions and requests through options such as RAG, request or agents and tools. They need to be able to, they can handle diverse data with their intrinsic semantic tools. LLMs in their name, large language models, have inherent language skills. And so being able to understand the same meaning, but different words or different spellings, different subtle variations, LLMs are great at that. Cost efficiency, there's already lots of robust built-in solutions being developed, both by proprietary companies with their own models, as well as open sourced models and libraries that work pretty well out of the box. You don't need to be training models like traditional ML. There's a lot of solid foundation models that can just be used. You can support your maintenance efforts by providing natural language interfaces to logs, even using it to execute common actions, clearing alarms, requesting updates. So there's a lot of power here. However, LLMs do come with their own challenges. One that I'll speak on a little bit in terms of security, but our security webinars are a great place to learn more. So from OWASP, they have a top 10 for LLM applications. I have 4 here that I wanted to speak to briefly. So prompt injection, for those that are familiar with SQL injection, it's somewhat similar where an attacker can craft an input that is manipulated to have the LLM do something different that isn't sort of expected, whether directly through that system prompt that's being passed to it or external inputs that are known to be utilized by an LLM, such as websites. These can lead to LLMs sort of jailbreaking, as a term, to perform actions that maybe weren't intended by the creator, but the model is technically able to do with tools it's provided. Model denial of service, very similar to general denial of service attacks where REST APIs or other services are overloaded, but there's kind of another angle with LLMs where simply just having a very large prompt, if not sort of guarded against, could just incur really high resource costs, both in CPU and RAM, as well as charges to your provider if you're paying per token. And so being aware of that sort of attack is important. What is the typical size of a prompt that you would expect, and not really allowing just any sort of free text to go in. Sensitive data exposure. This one kind of pairs with the one next to it, excessive agency. LLMs, if they are interacting with some of these sensitive pieces of information, whether knowingly or unknowingly, it could expose it. An example would be kind of paired with the excessive agency is you have an agent that can both query APIs for information as well as retrieve data from a database. It may not be intended by you that it takes data from the database and injects it into a query, but if you're not guarding against those things, that could be something possible. And then the endpoint, is receiving sensitive information that wasn't necessarily intended. And so for more security information, which we could spend a whole webinar on, take a look at our security team and dive deeper in there, as well as our articles. In addition to security considerations, we do need to account for diversity in data formats and structures, like mentioned earlier. And so this is a challenge both within sort of traditional methods, and LLMs do help with this, but really the thing that is especially important for an LLM is having something that's semantically relevant or useful. In the example here, I've kind of some different versions of what an error might look like. Maybe it's in JSON as errors or error list, machine errors, or XML with some structure there, or even just a log file that says, ID 53, power failure. All of these at least have some element that is, understandable, as this is sort of error information. So an LLM could extract that out. However, if there's isn't sort of these relevant names, there isn't a lot an LLM can do without you injecting additional system prompts to explain, okay, this list of integers actually refers to certain error codes. It can only know and reason about what's in your data. It doesn't necessarily have, it can't just know that things that aren't explicitly there. So let's talk about some approaches for handling these sorts of data. So 4 approaches we're going to talk about today are JSON agent, RAG, retrieval augmented generation, full context, and generative tools. So let's take a look and walk through them one by one. So the first is JSON agent. It provides the ability to iteratively traverse JSON files or similarly structured, as long as you can load them into, say, your Python or other code as an object that can serialize to JSON. It's really the LLM that's looking at the JSON versus what your content's explicitly saved as. And so what it does is it basically loops through. If you look at the image on the right, it can either get a value from a specific key or it can list keys. And so it iterates over and over on this data, asking tools to retrieve this information. So it's able to take in the requested information of what are the required parameters in the request body to the completions endpoint, and dig down into paths, and then what are the endpoints that are in this document, and find, model is the required parameter. So really the under con, I put each search is nearsighted. It's also kind of a pro in that it's always going to look at either the specific value as mentioned or a list of the keys at a certain key level. And so it's a pro in the sense that it keeps token costs small. It's not putting the entire document into the LLM every single time. It's just small bits of information. But there can also be a con in that if the document is, deeply nested, it could take a while to iterate down and find semantically relevant key names to be able to search and find sort of the answer to your question or your request to extract data, format it a certain way. So it's kind of similar to the JSON agent, is the retrieval augmented generation, or RAG. This will rely on the answer being found in a specific segment of the content. The sort of step up here is that we're able to not just dig into specific keys at a time, but we can kind of determine certain data size chunks of information. A lot of common sort of hello world examples of this are scholarly articles, being able to find answers to questions within a large database of information, but it can also be used in this context to look within the structured or loosely structured data and find specific pieces of information. The advantage here over the JSON agent is, the relevant context is a bit larger. You do have to pre-process in order to do the chunking and embedding generation. The embedding models are generally cheaper, though, than sort of the chat and instruction-based models, and so those costs aren't as large as some other options. Hallucinations, while minimized, can still occur. Chunk and overlap sizing can need tuning, so your different documents are broken down into parts, and they can have overlap so that things that are relevant in one sort of the left-hand side, let's say, can overlap into the right-hand side to be able to answer questions about both pieces. It does have the ability that you're querying across many documents to find something that's similar and put that into your prompt as context. This enables you to get again across lots of documents, but the limitation is, you need the specific sort of answer in in it somewhere. Needle in a haystack. If you're looking more for a summary or aggregation of data, this won't really be able to do that because it's looking for a specific thing to sort of solve your problem. And so alternatively, if you need sort of reasonable or along a larger amount of context, using the full document itself as context can work. The larger and larger context size over time, as new models get developed, you can see on the right, the bars just exponentially grow as we build more and more models, and even theoretical infinite context models are being developed. So super powerful. It really is becoming less of is technical possible. The tech seems to support just putting a ton of stuff into context and answering questions about it. Really, it comes down to the current sort of industry approach of billing for LLMs. Vast majority are on sort of a certain amount of tokens equals a certain amount of dollars. And so while you could put all your documents into context, answer some questions about them, it might cost you a lot of money. An example is a half a cent per, say, a megabyte document or so for an audit with GPT 3.5 Turbo versus like GPT 4 Turbo would be like 10 cents. So it can get up there. But this can be really powerful both for even just a quick start. So if you're on the development side and I just want to see how an LLM can reason about my document or my data, this can be really helpful because there's really no setup. You're just literally copy pasting into a chat window or into the Python interface that you're using. And so it's a very easy way to quick start and even transition to some of these other methods. But also if you have, say, a smaller group of analysts that are trying to, dig into certain errors and understand certain documents, this can be still helpful because, maybe you spend 20 to $100 a month on LLMs, but it helps you understand your data. That's a pretty good trade-off. But if you have millions of users hitting your service, this probably isn't the route for you. Lastly, if there's a need for sort of the really high consistency and precision that you've gotten with writing those traditional brittle parsers and tools, then generative tools is kind of a in-between space. We're able to, just like developers have been finding that they can ask LLMs to write code for them based on a statement, as well as write tests. We can take that principle and apply it here where we write out what are some of the functions that we would want in an abstract base class and have the LLM write the child class for you based on a sample document. So here we can utilize an LLM to support multiple audit types and scenarios and different data structures, but write us code that can be tested and deployed and either used just standalone as a traditional software application, or it can be supplied to an LLM as a tool that it can use to answer questions. So you can ask for what is the average error quantity of errors for a particular location in the past 7 days. It's able to go run this tool, grab that information, parse it the way it's been determined to parse, and give you that answer as a summary. So sort of the pro, you have the flexibility of all those different data formats, and you're going to get a specific, even strongly typed answer back with different data schemas you can apply. Really, the con is it does offer you more code to maintain, as well as would definitely recommend a strong test suite to be successful in this. You want to, especially as you add additional child classes, you want to make sure that they're all sort of, even though they're parsing the data in different ways, arriving at sort of the same response objects and outputs in terms of types and structure. So it can be really powerful, but does require a little bit more. So let's kind of look in summary how these different options compare to each other. There's definitely trade-offs for different approaches. I kind of put 4 measures here of cost in terms of dollars, speed, maintenance, and capabilities. For example, a JSON agent, quite financially reasonable because of those small context sizes it's iterating over. Speed can be kind of in the middle because it can take some time to keep iterating through that loop to find the information it's wanting to. Maintenance isn't too bad. There isn't really any pre-processing you're doing. You're just sending the data to it through these tools. Capabilities I mark as red just because it needs somewhat more shallow documents and needs a lot of that semantically relevant information for it to be able to step through. RAG, it's definitely a solid approach. For other spaces, these might be more green versus red, but here I can put dollars in the middle. It's using still a small amount of context in the question to the LLM, similar to JSON agent, but you do have to run that and maintain that vector database with your embeddings. And so that sort of dings it on dollars and maintenance in my mind. And capabilities, it's a bit better and expansive, but it does require that, needle in a haystack approach where you have to have the answer you're looking for in the data as opposed to necessarily reasoning around it or summarizing it. Full context, I think it's very fast. There's no maintenance. There's no setup, like we said. A lot of capabilities to just ask questions about the data, but the cost really does weigh it down. And lastly, generative tools. Dollars, it does a lot of the sort of document content processing in code versus the LLM. And so what actually gets sent to the LLM is just the results of those tools processing the data. And so it's also quick that way. There's not iteration. It's just calls the tool, returns the information. Maintenance, we need those tests. We need to add new methods to those abstract based classes if there's new things we want to extract. So there's a bit more there, but it definitely is strong in capabilities. Really, there's no one size fits all approach. You can either, it's also not necessarily picking just one of these. There could be a combination depending on what you're trying to accomplish. And so you need to consider the trade-offs. And so some quick rules of thumb, when to use these. JSON agent, you really have that shallow structure with semantically relevant keys to go after specific information. RAG, similar to that, but information is within a segment of data somewhere, and you need faster results than the JSON agent sort of iterating over and over to dig down into a specific document. Full context, really good at the quick start to see what's possible, or complex questions with low volume. So you're able to, have that smaller analyst team versus a full customer user base. And lastly, generative tools, you want those more consistent outputs, summarizations, calculations, transformations, and kind of using the LLM as an orchestrator that chains together different tools to obtain information and organize results, as opposed to really trying to process the content itself. Regardless of the option you choose, though, testing is very important. Sort of our traditional software development approach, we have unit integration system testing, traditional ML dev. We're looking at ML engineers doing a lot of the implementation, similar to software engineers, with our ML scientists really focused on the model performance testing. With generative AI, it kind of flips things a little bit on its head, where we really need the ML engineers and scientists working together on the implementation side, because so much of it is really just getting these models and tools and approaches to work how we want them, as opposed to explicitly training a model and seeing how it performs. We're working with a lot more foundation models that are already trained and getting them to perform in certain ways. We want to really integrate the ML scientists into the system and integration testing as well, to understand not how specific results are. We're not necessarily asserting that the output is a specific string of text, but really making sure that things are processed in the way we expect them to. So for a RAG, for example, that it's utilizing specific documents as context, and ranking similarities the way we would expect. And for generative tools, making sure that the correct tool is used for a prompt, as opposed to a certain result being what it is. A lot of it comes down to making sure the process is performing how we want it to, and not just on asserting a specific answer is given, or that a certain metric of accuracy is provided. So now I'll pass it back to Yachi and talk a little bit about what the future holds.
Thanks, Jeannie. That's a lot of challenges and really hands-on experience that there's even some secret recipes were accomplished and derived over the course of last year or so. What I'm showing here is our last slide. And we really want to share our vision regarding how large language models can be even more powerful in its hyper-automation capabilities compared to today's already fairly established state of the art. Many of you are practitioners and decision makers in this space, so you kind of see the familiarity of some terminologies here. So when we compare large language model and today's state-of-the-art approaches to tackle data access, ETL, stand for extract, transform, load problems, they differ significantly in their methodologies, capabilities, and the benefits they offer. So here we come up with a fairly detailed comparison here for your reference. For data access, today's state-of-the-art rely heavily on structured data access protocols such as SQL queries, APIs, and direct database connections. These methods require a thorough understanding of the database schema and structure. On the contrary, large language model actually enable users to access data using natural language queries. So you don't really have to be really a data guru in order to do some simple queries, eliminating need for understanding the complex query language or database schema, really achieving the no code to little code of a domain. Contextual understanding is what kind of comes with the intrinsic nature of large language model. Large language model can understand and interpret the context of the queries, making it easier to retrieve relevant information without the detailed schema knowledge. So that's what we actually leveraged in the approach Jimmy mentioned before. In the ETL processes, as much as there's a lot of cloud vendor making the efforts to make the process as flexible as you can, we have to be honest that today's state of the art often involves writing customer scripts or using the tools to extract data from various sources, transform it into a suitable format, and load it into our target database. And the pipelines are usually predefined and inflexible. There are some wiggle room here. You definitely can make it flexible as you can. However, it requires significant efforts to make it flexible and to adapt to new data sources or changes in the existing sources. And in today's state of the art as well, handling complex data transformations and integrations require really the deep technical expertise and extensive coding. You really need to hire the best of data engineers to handle that for you, and that's really the unicorns in the talent market. So on the other hand, when we leverage large language model, they can actually automate the extraction of the data from those diverse data sources, including unstructured data such as text, documentation, emails, and web pages, compared to most of the structured data approach that today's data are often handled with. Moreover, the large language models can perform dynamic data transformation using the natural language model instructions, simplifying the process of cleaning, aggregating, and enriching the data. So again, leverage the intrinsic nature of this natural language interface. Last but not least is the adaptive pipelines that large language model can enable. It can adapt to changes in data sources and formats in a more flexible way, again, because of the way it was created, reducing the need for manual reconfiguration of ETL pipelines. The last thing we want to consider is definitely the maintenance aspect. For many of you as the practitioner, this is not really the fun part of their work. So in today, maintaining the ETL pipelines involve continuous monitoring, debugging, and updating to handle the changes in data sources or requirements. Things become very rigid, and you have to be really careful, have a good pair of eyes to make sure everything is correct. However, on the large language model side, it can reduce the maintenance overhead by automatically adjusting to the changes in data sources. If you can do it right way, it can handle the errors with minimum human intervention. So that's what we call it, the hyper automation, to really help you navigate the complex problem space. So our vision is really by enabling the large language interactions and adaptive data handlings, they can significantly streamline and enhance the data handling process, make it more accessible and efficient for a broader range of applications than you would ever imagine. So I believe you also see some of the use cases Jimmy has mentioned from today's webinar already. So we're really excited to be here and look forward to helping you and your organizations become a true leader in this Gen AI journey. So with that, I want to move to the Q&A.
Yachi, Jimmy, thank you both very much for a really great articulation of not only where we see generative AI going. I mean, ultimately, we hear about generative AI a lot, and we hear about things like writing an essay for one of our kids, sort of assignments or something of that nature. But to see how it's going to fundamentally change how we do our work as technologists, how it's going to change the opportunity to create systems for clients. I'm not sure there's anything other than maybe the mouse that's is potentially impacting the kinds of business workflows we have an opportunity to unlock. So we would love to hear from you as we start our Q&A. One of our administrators posted a quick little poll here. If you don't mind, I'd love to hear your feedback. We'll try to pull that together before we're finished here today. But maybe to start us off with one of the questions that we had submitted, we heard from Jimmy in terms of how some of the playbooks have informed and shaped our decision making and how we execute. But Yachi, I want to ask you sort of, to execute is one thing. To get the opportunity to execute is something a little different. If an organization is unsure, they have some resistance to trying out or leveraging generative AI, what are some things that the playbook would help a client understand and overcome that resistance?
Yeah, that's a good question. And I have to be honest, like our organizations in the past year or 2 years, we've been through that exactly situation journey. It's not more of a resistance, it's more of a awareness. So definitely the education awareness is the first step. And if you recall the slides I showed, the playbook benefits, one of it is the strategic alignment. And that part is also echoes here when we try to engage the stakeholder early. There are some practice we deployed within our own organizations that we kind of assembled the upper leadership agreement and with all the polls and opinion gathering from the broader organization members. So all in all, I think a lot of we have very detailed learnings we documented about our journey. I think that sounds like it's a good opportunity to publish those learnings we have experienced ourselves and want to share that to the broader audience as well.
Excellent. I think that's great advice, Yachi. So maybe a little bit for you, Jimmy, but also Yachi in a holistic way. I mean, when you think about building teams, and Yachi or Jimmy, you mentioned this a little bit when you were describing, building generative AI solutions is different than building more traditional AI model-based solutions, right? Where the data scientists and the data engineers, the ML engineers, they're really focusing on the model and getting that released, right? Because generative AI has the opportunity to impact the entire user experience of a system. Now the team has to be involved in that quality testing and whatnot, sort of throughout the entire life cycle, more like a software engineer in more of a traditional sense. So when you think about that, what is some of the best practices to building a team? Because assuming that building a team for generative AI solutions looks similar, but perhaps a little different than what it may have looked like building a team who's just going to build more of a traditional AI ML model.
Yeah, I think partnering, your data scientists hats with your data engineering hats or ML engineer hats is important. I say hats because a lot of these teams are built in an aggregate of these skills. It's not necessarily one person with data science skills and one person with engineering skills. Um, but as you alluded to, there is sort of this user experience element that I think we're also haven't necessarily interacted with. A lot of data engineering. You think of ETL pipelines, right? Those aren't being run typically by your customer, your end user. And similar with models, traditional ML models were behind some REST endpoint that was called by an application to get a specific prediction classification. But now we as data people are getting even closer to users. We need to start thinking about not just what would I type into a prompt or ask of a model, but what is your user going to do? Do they need training on how to adequately make requests of this system? Do they need to, have certain guidelines in the UI of, or sample prompts? There's a lot of skills that maybe us data folks haven't always exercised or stretched that we'll need to learn from some of our UI UX friends. Um, in addition to that, a lot of the training in the past, while GPUs were obviously very helpful for a lot of deep learning development, you could train some models on your machine. Here we're shifting to more of the foundation models, and maybe running tuning jobs. A lot of this is going to require more sort of cloud skills and different platform skills, learning whether it's OpenAI or Google Cloud, AWS, Azure, these different platforms, how they support, model usage and tuning will be important. That was not as hard of a requirement before, or maybe was walled off from your data scientist before and handled by a separate team. They'll need to interact a little more closely with those tools.
Excellent. So Yachi, I want to bring a version of that question to you now. As you're executing with a client the playbook, and you're looking at their team, you're looking at the client, what their skills are, how they're approaching it. How does the playbook help inform that dynamic, creating that experience and opportunity that Jimmy was describing?
Yeah, so if you think about 10 or 20 years ago, how data science become a thing, as fluffy or buzzword as it sounded like, people started to shift their statistical team or like converted some non-data folks to data center of excellence. We're experiencing that journey pretty much one more time in that regards. So the type of skill sets when we think about in generative AI space is nothing kind of different directionally when you think about building an application. You still need the kind of the UI, the backend, and the machine learning components. It's just you need the core machine learning engineer and scientist to really understand how the foundation model works and things like that. The good news is that there are a lot of accessible resources online everywhere that are help you and feed where you are to get to the next level. And unlike when we think about training a data scientist or data engineer from a college, like 4 year of a program, when I look at the skill sets required for the generative AI courses and all the trainings I've seen so far, it doesn't really require a lot of like math or algorithm background in order to become very proficient in this space. So we actually see that as an advantage to our organization, since we have so many experienced software engineers that showed great interest and can really get up to speed very, very quickly to those tools and contribute very quickly. So I see this as an advantage compared to going through very rigorous university and academia training.
Excellent. Excellent. Okay. Yachi, question for you then, kind of taking it the next step down is, when we're thinking about AI now in this broader context, this broader potential scenarios, how it could be impacting customers, business users, and so forth. How should customers think about selecting and identifying that right use case? How do they prioritize that, and how does the playbook set them up for success in that regard?
Yeah, that's a very hard. It's easier said than done for this problem. If all organizations can do it well, we'll already be very advanced in all those applications. So I think in general, whether it's AI or generative AI, the fundamental understanding is you need to understand the capability and you understand the value, the piece. And the capability piece is you need to understand what differentiates the foundation model and the large language problem from itself. It's not going to be excelling at everything. For example, I think if you can try this simple logic problem to ChatGPT or any other tools, the generative tools, you ask them like, if Alice has 2 brothers and 3 sisters, how many brothers are those sisters have? This is a really simple kind of logic questions, but most of those tools will fail. So those tools, they're not really good at understanding the boundaries of the problems. They're not really good at understanding some of the very simple logic and the mathematical principles. However, what they're good at is summarization. They are good at memorizing a lot of things, and they're good at a lot of the repetitive work that humans like us, we are really tired of doing. Like, we are not really skilled to do. So understanding that part is very important. And the second part is, now you can start to look at in your business use cases, what are those opportunities that can be very tedious and expensive for people to do, but actually turns out to be very easy for the large language to do. We have more details kind of decision tree or playbook rule of thumb for organization to follow, probably more strategic than what I just said, but just want to give folks an example of where we have the right expectation. Like, it's not a silver bullet for everything, but it's also if you can do it right, then it will make things way better than what it is now.
Excellent. Thank you, Yachi. Yeah, maybe we're getting close on time. I'm going to have one more question, and then if there's anything from the those listening in today and they want to post, please put those in the chat, and the team will pass them along to us. Jimmy, I know broadly when we look at the clients we've been engaging with, we not to generalize it too much, but we either have clients that are like they've already thought through the generative AI journey and they're looking for someone to help accelerate them in through implementation, or we have clients that are familiar with AI in general, but they're like they want to experiment with generative AI, and they're looking for someone to walk with them through that journey together and overcome pitfalls. And on the latter group, a lot of times one of the things that's holding them up from running fast is security. And you mentioned earlier on that one of the key considerations is data privacy, PII information. So how are you helping clients understand the security component in terms of what is good security, what is like what is good sharing. You know, like I've heard people in my own social circles share like, well, if I give all my data to ChatGPT, are they going to know everything that I know? I don't want to give them that. How do we prevent that? So is there a couple of tidbits you can share to alleviate people's concerns around that there are good solutions? And what would you share with them?
Yeah, I would start with, part of the what I do in just my day-to-day job is I actually read some of those super long terms of services that we all click yes, I agree to. Um, looking into ChatGPT and understanding really what are they saying they will and won't do with your data, and even helping educate people what those things are, such as even the differences between when you log in as a personal free account user to OpenAI.com versus an enterprise paying customer into their API service, are different terms of service and different offerings, as well as what the different cloud providers offer. Um, to some degree, that they do have notes on improving their services, but there are a lot of explicit mentions of not using it to train models. And you can also see that some of these companies are going into large partnerships with other companies for data acquisition. So they are, spending a good amount of money going after data since they aren't using yours. But even if still are concerns, there are also options for deploying some of these more open models like Llama 2, and being able to truly control all the data within your data center, um, or you could run those models on your chosen cloud platform, but not use the managed service. Um, but lastly, there are good practices and tests that you want to develop to, do you really, even though you're working with, say, sensitive data, do you need to send certain elements of that to the LLM, or can you obfuscate it in some way, or sort of translate it into something equivalently useful in terms of semantics, but not an explicit name or address, or determining what's really needed out of your use case, and
Hmm.
making sure to sort of mask those things. And of course, along with your own custom detection, there's many services out there that help scan text before it goes somewhere to determine if it's got sensitive info. And so you can add sort of a quick leg in your journey before your prompt goes to an LLM to check. And that can also help with your users, because as much as you spend time on, okay, we're not going to pull their sensitive data out of the database and send it to an LLM, sometimes people just type sensitive info into free text fields, and being able to help protect your users from any sort of exposure there. Because you may want to log user prompts, for example, as a reasonable thing to do, to say, I want to understand what people are asking our service. But if there's sensitive data in there, you wouldn't want to do that. And so making sure that not just the data you're passing around, but what people are providing to you is being monitored.
Excellent. That's great advice, Jimmy. Thank you for sharing. Um, Everyone, this is I think we're coming just in the last couple minutes of our time together. Thank you all for participating and sharing. Yachi and Jimmy, thank you as well for unpacking this playbook with everyone today, providing some clear examples, and then digging in deeper with some relevant insights into how this journey can unfold. If you would like to learn more about object computing, like to learn more about our playbooks on generative AI and other areas of interest, please reach out to Matt Bremer. Matt is our director of sales here at Object Computing, and he will make sure you get connected with all the right teams here with us today. Everyone, have a great rest of your day. If you're watching this in the future, have a great day, and look forward to seeing you at our next webinar.
Thanks, everyone.